Sure, Troy. Welcome, everyone. Nice to see everybody back. This is our start of our new Learn With Us season. And we thought we'd start with a bit of a bang today on the topic that's kind of on everyone's lips, which is artificial intelligence. And we needed a place to start. And thank you, Daryl, for doing the first presentation for us. Many of you know Troy, who from our other Learn With Us sessions, but Daryl isn't always on our sessions. Daryl is one of the other partners at Western IM, and we worked together for a lot of years. Daryl is our director of professional services at Western IM, so he gets involved in a lot of this stuff as well. And so the first session is really going to be the foundation session, talking about AI and its kind of base concepts and how it works and that kind of thing. And I'm really looking forward to the presentation, Daryl. Daryl did record this one, so we'll play that, and then we'll all be back after the recording is finished. And thank you again for your attendance, everyone, and good to see everybody again for a new Learn With Us season. It will be a 4-part session, though. This will be a 4-parter in the month of October. So really looking to learning together as a group a little more about AI as we go forward. Thanks, Troy.
All right, I'll go ahead and share my screen here, and I'll start the video, and then we'll come back afterwards here.
Hello, I am Daryl Schrader, Director of Systems Integration at Western Information Management. And if you're listening to this, you're hopefully here for our first session in this year's Learn With Us series, AI and RM. If you aren't familiar with the abbreviations, that would be Artificial Intelligence and Records Management. It would be hard to be unaware of the current buzz around artificial intelligence. It seems that everywhere in the popular media there are articles or podcasts or webinars about AI and its implications for this or that. And since we aren't immune to that buzz, we thought it would be good to look at artificial intelligence and see what, if anything, it has to do with records management. Spoiler alert, we think that AI techniques can be very relevant in managing your organization's records. In this session, we'll look at what AI is, particularly in its current popular incarnation. This will necessarily be somewhat technical, but I'll try to keep it at an introductory level. In a subsequent session, we will look at how Western IM uses AI to facilitate records management, using our own software tools as examples of what is possible. Without further ado, let's jump right in. As always, I like to start off with a somewhat obscure quote and use it to set context for what I'm talking about. Here we have a quote from James Autry, a Fortune 500 executive and motivational author who has written, "Data are not facts. Facts are not information. Information is not knowledge. Knowledge is not understanding. Understanding is not truth. Truth is not wisdom." The takeaway here is that you can start with individual data points, and by adding context and connections between them, you add value, and you work up the hierarchy from data to facts, to information, to knowledge, to understanding, to truth, and finally to wisdom. This provides a way to think about your experience of the world and to structure those experiences in a useful way. I leave this with you for now, but we'll circle around to it again by the end. What is artificial intelligence? In common parlance, artificial intelligence is often synonymous with machine learning or neural networks. Another term that is often used is deep learning. Technically, deep learning is a subset of neural networks, which are a subset of machine learning, which itself is a subset of artificial intelligence. But in the media, these are often all simply referred to as AI, without further distinction, even though they can be quite different things. What is AI used for? AI is used in gaming, where it can be used to give non-player characters a semblance of independent action, so they don't just continually repeat the same actions. It is used in recommendation algorithms, such as in Netflix or YouTube or Amazon, where it can prompt, "You were interested in this thing, you might like this thing as well." It is used in natural language processing, like Siri or Alexa, to allow interaction with the system through normal speech. It is used in visual recognition, like when you tag someone in a picture on Facebook. Facebook can then find that person in other pictures and also tags them there. It is used in automated navigation, for drones, or soon for self-driving cars. And is used in generative AI, where the AI creates stories, pictures, or video based on instructions that you give it. So I hear you say, "Daryl, it seems like AI is used quite a bit in applications that we use every day. Why is it all of a sudden on everyone's radar?" I'm glad you asked that question, and we'll get to it. But first, a brief history lesson. I promise there won't be a test at the end. But as we say, you can't know where you are going unless you know where you have been. In 1950, Alan Turing proposed a thought experiment. He suggested that a person sit in front of a computer terminal. The person would have a conversation over the computer terminal, typing in questions or statements and receiving responses back. If the person could not tell the difference between when the conversation was with another person and when the conversation was with a computer program, then the computer program could be considered as an artificial intelligence. This became known as the Turing test and is considered a generic, if not entirely useful, definition of when something is an AI. By 1956, artificial intelligence had been established as an academic discipline, and by 1970, the theoretical basis of neural networks had been established. There were, however, no real-world implementations because computers were not yet powerful enough to make neural networks useful. By 2012, computers had become powerful enough to make neural networks useful in the real world, and they began to be used in some of the previously mentioned applications. In 2017, transformers were developed. And no, these were not cars and trucks that turned into giant robots. Transformers are a programming device that is used to implement large language models, which we will talk about in a minute. And in 2022, which was just last year, ChatGPT was released, becoming the fastest growing consumer software yet released. That's faster than Windows, faster than iTunes, faster than Office or Microsoft 365. That's the kind of growth that captures people's attention. So what's all the fuss about? Well, as mentioned, the current buzz is all around large language models, which are a type of neural network. Large language models analyze large volumes of language, or text. They then model the language so that if you give it some text to start with, it can predict what subsequent text is likely to be. There are many different large language models. GPT, which is the one used in ChatGPT and in Microsoft Bing, gets the most press. But there is also Bard, which is used by Google, Llama, which is used by Meta, which is Facebook, and Bloom, which is open source. There is also Ernie, which is developed by the Chinese company Baidu, and Claude, which is a new model being touted as responsible AI. All of these are in a class of AI called generative AI, which means that when given some text as a starting point, it generates new text that follows naturally from the initial text. In practical use, the text given is usually in the form of a question, which means the subsequent text will be an answer. In this way, it provides access to general knowledge. For example, if the text you give it is, "What color is an elephant?" it has analyzed enough text to know that when the words color and elephant are combined together in the form of a question, then the text that is expected to follow will be some form of "an elephant is gray." In this way, large language models encapsulate general knowledge about the world beyond simple lists of facts. Large language models go beyond simple single-word concepts like elephant, color, and gray, and can expose connections between concepts expressed in multiple words, phrases, or sentences. Because they expose connections that may not have been immediately evident, they can appear to be quite smart. Let's take just a few minutes to discuss how these large language models work. Obviously, this is a hugely complicated subject. I could do an entire 40-hour course on this and not completely do it justice. But let's try to get at least a simplified understanding of it. Since large language models are a form of neural network, let's first look at how neural networks work. This is a simplified diagram of a neural network. The input is fed in on the left. Each circle represents a node where some action is taken to modify the input and create an output. Each arrow out of a node represents that output being fed as the input to more nodes. Each arrow is assigned a weight, which gives the relative importance of that input in comparison to all the other inputs to that node. The first layer of nodes is known as the input layer, and the last layer of nodes is known as the output layer. The layers in between are known as hidden layers. This is a very simplified diagram. The neural networks used in large language models can have 100 or more hidden layers. The final output of the neural network will be determined by the action that is performed by the nodes, the way that the nodes are connected, and the weight assigned to each arrow. Changing the layout of the nodes can optimize the neural network for solving different kinds of problems. The layout of the nodes and the action that is taken by each node cannot be changed after the network is created. The weights assigned to the arrows can be changed in a process called training. In training, an input is provided where the desired output is already known. If the network generates the desired output, the weights are reinforced. If the network does not create the desired output, the weights are adjusted to create the desired output. Over thousands or hundreds of thousands of iterations, the network will be trained so that for any given input, the desired output will be obtained. Neural networks like this provided indifferent results for generating text until the development of transformers in 2017. Transformers replaced the nodes of the neural network with a new way of generating text. Let's look at how a transformer works. This is a simplified diagram of a transformer. The transformer is divided into two parts, an attention layer and a prediction layer. In a sentence, not all words are equally important. Some words might be changed without altering the meaning of the sentence, while changing other words completely alters the meaning. The attention layer looks at all the words coming into the transformer and determines which of these words are the most important. The prediction layer then looks at all of the words and, depending on how important each word is, predicts what the next word in the string might be. That word is then added to the input text, which may change the attention values of the previous words. The next word is then predicted using the new attention values and is again added back to the input. This continues on, creating a string of text that is appropriate to follow the initial input text. Let's use our previous example. What color is an elephant? The text goes into the input. For convenience, we show that the text also goes into the output. The attention layer looks at the text. The important words for the next predicted output are what, is, and an, plus the question mark. These suggest that the next word should start an answer about a single object. The words color and elephant really don't affect how the answer should start. A good guess for the next word is an. We feed the predicted word back into the input. Now the attention layer looks at the input text and finds that the important words for the next prediction are elephant and the predicted word an starting the answer. Because the input word is elephant, it wouldn't make sense to predict buffalo or violin, and because we started with an, we don't want a plural. The only reasonable guess is elephant. Again, we feed the output back to the input. Now the attention layer tells us that the important word for the next prediction is. The input text is present tense, so it wouldn't make sense to predict was. It might make sense to predict has, as in an elephant has gray skin, but our prediction layer opts for the more obvious is. Again, feeding the output back to the input. Now the attention layer says that the important words are color and elephant. From training, it knows that the word most often associated with color and elephant is gray. It might also choose a modifier such as light or usually, but again, we choose the more simple gray. Again, feeding the output back to the input. Now the attention layer suggests that the important bits are the question mark and the words what, color, and gray. Put together, they suggest that the question has been asked and answered. Training suggests that once a question has been asked and answered, you stop. So the prediction layer suggests a period to end the sentence, and the period is fed back to the input, which tells us to stop. We've seen that a transformer uses attention and prediction to create text, and neural networks weight the output of many transformers in order to pick the best response. How do we know what all these values are? They come from a process called training. We start by training the transformer. A large amount of text is analyzed, and the relationships between words are assessed to determine which words are important and what the probability is for a given word to follow that set of important words. Once the transformer is trained to create text, the neural network itself is trained in 2 steps. The first step is automatic training. The neural network is presented with the first part of a known text, and the output is checked to see if it matches the second part of the known text. If it matches, the weighting of the outputs between the transformers is reinforced. If the text doesn't match, the weighting is adjusted. This is done many, many times until the output of the neural network consistently matches the part of the input text it wasn't given. The second step is manual training. In this step, the desired output of the network is not known in advance, but a human judges the output and determines if it is good or bad. After many results, the system is scored. The weights in the network are then adjusted and the process is repeated. The scores are compared, and the weights corresponding to the better score are kept. This is repeated until the scores can no longer be consistently improved. How much text is used in training? The short answer is all of it. As an example, GPT was trained in 2021. The text used for training was basically all of the text publicly available on the internet. This amounted to 75 terabytes of text, or about 100 trillion words. It took 355 years to train. Now, obviously, it didn't take 355 years from start to finish, but it took many computers working simultaneously on different parts of the problem in order to finish the training in 1 year of real time. To put together the computers to complete the training, Microsoft provided a dedicated Azure data center, and while the cost of that data center is not publicly available, it has been reported as being hundreds of millions of dollars. So, what does all this investment buy us? As we've seen, a large language model basically mines all of the text on the internet to find and expose connections between texts. It knows that elephants are gray, or that Toronto is in Canada, or that whales swim in the ocean, because those sets of words are commonly found together. This creates a general knowledge base without having to find and tabulate all of the separate facts. You can ask it any question, and a large language model will formulate the most likely answer based on all of the information available to it from the internet. A large language model works best with large amounts of text. The more text you give it, the more connections it can make, and the better the responses will be. If you ask a single question, you will get an answer. But if you ask a follow-up question and ask for clarifications, the answers will become more in-depth and more nuanced. This makes a large language model responsive. The more you interact with it, the more text it has to work with. The large language model will incorporate not only the text you provide, but also its own previous responses. This gives it a thread that connects its responses, not just individual disconnected facts. Unfortunately, there is a flip side to the coin. There are some things that large language models are not good at. Because large language models require such a significant effort to train, they are not good at recent information. For example, a large language model cannot be expected to answer the question, "Who won the game last night?" It simply doesn't have access to information that is that recent. Because large language models depend on finding connections between texts, they do not do well with esoteric or infrequently mentioned information. For example, you could not expect it to tell you the title of my daughter's PhD thesis. There are simply not enough references to it on the internet for the model to connect her name with the words in the title. The same lack of connections makes it difficult for large language models to deal with snippets of information. You need to give it enough text to start with so that it can begin making connections. They don't do well starting with one or two words, but also they don't do well with simple yes, no, or true, false answers. The answers tend to be quite long and wordy. They are difficult to correct. The connections that they have are the connections that they have. Just because you tell it that it is incorrect or that it has misunderstood is not enough to cause it to reconsider its answer. The response will always be generated from the connections that were created during training, even if those responses are incorrect or invalid. This is referred to as hallucinating, where the large language model creates incorrect output that is generated from incorrect connections. And because training takes so much effort, retraining to make new connections is quite difficult. While large language models are responsive, they are only responsive. They always follow the text presented to them. They cannot make inferences as to what you want, or discern if you are not asking the right questions to get the information you are looking for. They cannot suggest a different way of looking at things. They can only follow what the user provides. And large language models can't provide references as to the source of their information. The responses are created from analysis of the entire body of text they were trained on, the probabilities and weighting of connections, not from reference to a particular source. So as there is no way for them to justify their response by pointing back to another authority. Because the large language models aren't good at these things, there may be a preprocessor that will analyze the given text and determine if it is appropriate to submit it to the large language model. If not, the prompt may be submitted to a regular search engine instead. For example, ChatGPT normally queries only the GPT large language model, while Bing Chat tends to use the Bing search engine to first locate information, and then uses GPT to create a natural language summary of what it found. Now that we know how a large language model works, how do we actually use one? Here is a screenshot of ChatGPT. At the top, you can select which GPT version you want to use, and then there are a few examples you can try to get you started. To use ChatGPT, you just type your text into where it says send a message. Note that people normally type in a question, but the prompt doesn't have to be a question. It can be any string of text, and the AI will generate text that it predicts would normally follow that text. There are a few things you can do with your prompt that will improve your results. Be specific. A vague prompt has so many possible connections that it's unlikely to generate exactly what you are interested in. What kind of dog should I buy isn't likely to produce useful results. Define your context. The AI can't infer information from what you type in, so you have to include things that might affect the result. Something like, I'm an elderly gentleman living in a small apartment downtown in a large city. I'd like to get a dog to keep me company, but I need one that is easy to take care of. Can you recommend some dog breeds that I might want to consider? That is likely to at least start you in the right direction. Make sure your prompt doesn't contain spelling or grammatical errors. Errors in the prompt can cause the attention layer to incorrectly identify which words are important, causing the prediction layer to incorrectly generate the output text. If possible, define the output format. If you want a numbered list, say so. If you want a paragraph of explanatory text, put that in the prompt. If you have a target audience in mind, you can ask to have the answer structured to appeal to that audience. You can also ask for an answer in the form of a haiku, or ask for it to sound like a pirate. I'm not sure how useful that is. Use as many words as necessary. The more words you use, the more connections the large language model can make, and the more specific the response will be. Here is the input screen for Bard, the AI for Google. Again, it has some examples you can start out with, and a place to enter your prompt. You can see in the middle there is an option to pick up on the last question you were asking. This demonstrates one of the most useful features of the large language model, the ability to string questions together so that each subsequent question builds on the questions and responses that came before. Bard calls these strings of questions conversations, while ChatGPT calls them chats. By creating such a string of questions, you can expand or refine your questions. Each additional question brings additional text connections into play, allowing the large language model to more accurately predict relevant text. You can use follow-up questions like, what about if? Or, can you expand on that? This helps the model zero in on the answer you are looking for. You may also want to vary the phrasing of your prompt. The attention layer uses the specific sentence structure to determine the relative importance of each word. By changing the form of the sentence, you might alter what the model considers important, and thus change the text that it is generating. If you need to change topics, start a new conversation or a new chat. This way, your previous questions won't affect the new topic. Okay, we've spent a lot of time understanding what an AI, or large language model, is and how it works. But how is this relevant for records management? Well, a large language model exposes connections between texts in order to generate its responses. And a document is a text, so you can submit a document as a prompt. You can then ask questions about it, like, does this document contain PII? Or, should this document have a security classification? Or, when was this document approved? Or, what project does this relate to? You can then use the answers to the questions to extract metadata from the document. Also, a policy is a text, so you can submit a document as a prompt, and then submit a policy as a follow-up prompt, and then ask if the policy should apply to the document. A file classification system is also a text. You could submit a document and then submit your file classification system and ask the AI, where should this document be classified? You know what else is a text? A folder structure is a text. You could submit a document and then submit your folder structure and ask the AI, where should this document be filed? So sure, maybe the AI can do all that, but how does that make our life as records managers better? First, we have to recognize that the AI isn't doing anything that a person can't do. You could read a document and extract metadata, or decide if it is subject to policy, or classify it and file it away. What the AI provides is speed. An AI is faster at these repetitive tasks. Plus, it doesn't take lunch or coffee breaks or need to sleep. Scalability. You can always add more computers to make the AI do more, but adding more staff is always the last thing any organization wants to do. Repeatability. An AI always does things the same way. Things don't get filed or classified differently depending on who is doing the filing. Zero learning curve. A computer starts doing the job on day one. It doesn't forget or have to get up to speed or require a refresher course. The takeaway here is that an AI can help you do a lot more, a lot faster. My analogy is that of a steam shovel. A guy can dig a ditch with a regular garden shovel, but if you give him a steam shovel, he can dig that ditch a lot faster, or he can dig a really big ditch. An AI can help you complete projects that you never thought you could do because they just take too much work. And so we circle back around to where we started. But now let's look at how we deal with each of these different categories. Data are not facts. We use databases to deal with data, storing each individual piece of data. Facts are not information. We use search engines to deal with facts. We can ask a search engine, when does the local Walmart open? Or what time is it in Dubai? Information is not knowledge. Web pages are used for information. If you want to know about keeping goldfish as pets, or the life story of Abraham Lincoln, you can go to a website for that. Knowledge is not understanding. As we've seen, large language models create connections between texts, providing a storehouse of general knowledge. Understanding is not truth. As we've also seen, large language models don't really understand anything. For understanding, you have to go to a subject matter expert, or SME. In our case, this is a records manager. An AI doesn't replace a records manager. It's a tool that extends and expands their capabilities, allowing more to be accomplished. And as for truth and wisdom, I believe that brings us to the end of this presentation. Truth and wisdom are beyond the scope of what I'm able to discuss here. Thank you for spending time with me today. Time is our most valuable commodity, so we do appreciate when you share time with us. On the screen is my contact information. If you have any questions or comments, please feel free to send me an email.
That was great, Daryl. I really enjoyed that a lot. And you know what? As many times as you might hear some of these things about artificial intelligence or chat GPT or anything else, that whole refresher of kind of where it came from and how it works and how it fits together is really, really good. And I really liked all the examples you used to kind of highlight some of those things in the presentation. So I really enjoyed that. And thanks for spending the time to put that presentation together for the start of our 4-part series on artificial intelligence. I don't know if I have any questions for you.
Just there was one kind of comment partway through there, just about some of the other generative AI stuff that's happening. Einstein, SAP's got theirs as well, Joel. So there are people kind of, now that this is out there in the space, kind of developing, whether it's an extension of existing large language models in things like co-pilots, or training their own models on kind of specific tasks when it comes to, like in this case, Salesforce and SAP will have a specific set of information and knowledge and training that it would want to be done on those models to facilitate what they're doing specifically, rather than just a generic one that we're kind of seeing out of ChatGPT. So there is quite a bit happening around these models as well.
And I guess we can also say, Troy, that the genie's out of the bottle now. Like we're not going to be putting AI back in the bottle again and capping it. I think the way the extent that everybody's using artificial intelligence from all over the place right now is just a sign that it's here to stay, and everybody in the world is going to have a use of AI going forward. So
yeah, and just kind of bringing it back to the RM world, is where does it fit in what we're doing on day to day? Because I think we're kind of over the initial hype of stuff. People are trying to start putting it into practical use
right.
now, kind of where the direction of this series will go, where we'll have a panel kind of discussing direction in RM and information management, but then also how we've implemented it in our software tools to actually do a specific task using kind of some of the existing models. So that's kind of the genie's out of the bottle, but how do we actually make our wishes?
Right. And what's good and what's bad about using AI for certain tasks as well. So I think we've all been in the RIM world, we've all been kind of party to the fact that we want to do projects all the time, but the time and effort it takes to actually do them and the cost kind of knocks them down once in a while. Maybe AI can help us to kind of get those particular things done better, faster.
Well, taking it back to Daryl's example, is that we wanted to dig ditches before, but couldn't. But now then we got the steam shovel and could dig all the ditches we wanted.
Right,
and
right.
We're kind of getting into that space with some of the tasks that can be done by these technologies.
Well, the material for the next session is going to be out pretty quick. Should be out to the mailing list sometime today, later today, I'm thinking. And I'll be doing that session. It's kind of a more inner look at some of the things we had to do to try and integrate the AI for the good of records and information management projects that we get involved in, and how that kind of fit together, and in a pretty candid kind of way. So looking forward to doing that presentation on the 13th of October.
Okay, that's gonna be on the 13th. Yeah, we'll get the registration out for that. And we'll also put this video together and have it kind of as a reference that will be sent around, so that people that didn't get a chance to see it could see it before the next sessions.
Yeah, just thanking everybody again for, I know it's Truth and Reconciliation Day on the weekend, and a lot of people will be taking today off, I'm sure, for that particular holiday. But I'm glad everybody showed up at the session, and please make it's available to everybody to go back and have a look at after the fact if they want to go back and explore Daryl's session again. And again, Daryl, thanks very much for putting that session together.
You're welcome.
Now that it's been a few days since you recorded it, is there anything you missed or wanted to add? You know how that works.
Yeah, no, I think I was pretty satisfied with the video. Don't really have anything else to add at this point.
Great.
Well, like Rick said, you'll be doing the next one, Rick, and the kind of presentation that we've got put together for that. But the one after that, I think, is going to be a panel, which will be more of a kind of broader discussion between not just the three of us, but I think we're going to have a couple other people there.
And our good friend Ken Oldenburger, who we've known for a long time, who I consider one of the best classification people in the country. Ken will be on that as a panelist as well. And looking forward to talking about artificial intelligence in many different ways during that panel discussion. So looking forward to the third session as well. And then after the third, or at the end of the third session, right about that same time, we're going to send out a survey to everybody that's on the list and get results back from the survey on AI questions. And what we'll do at the end is the fourth session will be basically a takedown on the results we got back from that survey. So I think it'll be really interesting to hear what everybody has to say. It's because it's all of us talking to each other, trying to come up with the right answers on this AI topic anyway. It's not just us as a panel, but our community, our RIM community, helping to chime in on some of that as well.
Yeah, there was one quick note here that I missed in the day just now. Daryl mentioned that AI does do references or citations, but could we design the output in such a way to force to include them? So I'm thinking kind of that's asking is, what's the bylaws for City of Saskatoon citing references from Saskatoon website?
Yeah, again, the large language model itself won't generate references because that's not the way it works. It hasn't gone to a particular location and found information, so it has nothing to point back to. It's just generating new text based on what it's predicting that text should be based on what the original text was. So a large language model itself just has no reference to point to. What some of the AIs do that, like I say, they have a preprocessor that can take the answer or the question that you're asking, and then if it's not appropriate for a large language model, it might submit it off to just a regular search engine or some sort of knowledge base that it can access. So if it gets handed off to those kind of things, then it can provide references. You can see that if you use Bing. Bing again tends to send your question first to the Bing search engine. It searches the internet for answers, and so then it will provide those websites that it found as part of the response back. And it just uses the large language model to generate text, explanatory text around the results itself. But again, in that case, it's not the large language model that's providing references. It's the Bing search engine itself that generates those references.
Yeah, it had to happen to me on the weekend, Daryl. I had an issue in my Outlook after the last update, and I went in to try and get an answer to that. And of course, I used Bing to do that. And what happened was I asked it specifically about Office 2021, and it came back and said, well, actually, that hasn't been released yet. And I had to stop and give my head a shake for a second. Yeah, they stopped training it in 2021. So at that moment in time, they didn't know that 2021 had actually been released for Office. So I forgot, right? And I had to stop and think about it for a minute. Anyway.
Okay. Well, there's I don't think there's any other questions here. We can probably keep this one a bit shorter since it's kind of the introductory one, and we'll put together material for the next session. I know, Rick, you've already got most of your presentation ready for that one, so we'll get that
yep.
here.
Well, let's see. I'm working on it, Troy, and it will be ready by the 13th for sure. Okay. Thanks everybody for showing up, and I'm really excited to kick off our new year for the Learn With Us series, and looking forward to this whole 3 or 4-part series actually on the artificial intelligence piece. So really going to enjoy it, and see everybody hopefully for the next one.
Great. Okay, thanks everybody. Have a good rest.
Have a great week.